Hello everyone, welcome back to Senko. Today we are discussing another lead code daily question, that is minimum score of the path between two cities. Okay, so let's try to understand the question by reading the question. Okay, you're given a positive integer n representing the n cities numbered from 1 to n. You're given a 2D array roads where roads of I contains a b means there is a road from A to B and distance between them. Okay, uh, indicates that there is a bidirectional road between the cities. Okay, so it is undirected graph, you can say that. Distance equal to d. Okay, distance. Okay, the city graph is not necessarily connected. Okay, the score of the path between two cities is defined as the minimum distance from the road in this path. Score of the path between two cities is defined as the minimum distance. Okay, no problem. Return the minimum possible score of the path between 1 and n. Okay, a path is a sequence of road between two cities. Okay, there may be many different cities located between 1 and n that we need to cover first to reach n. Okay, it is allow for path to contain the sample road multiple time. Same road multiple time भी ले सकते हैं हम, उसमें भी कोई problem नहीं है. Okay, the test cases are generated such as there is at least one path from between 1 to n. So it is granted that there will be must one path between 1 and. Okay, means 1 2 4 or 1 4 1 2 3 then 2 then 4, like this there will be must be one path. Okay, in this case 1 to 4 this will must be one path. Okay, so let's see what this really means. So here we have the score as this is the graph and this is particular the two-dimensional grid that we have. So let's understand this question. So here we can go from 1 to 2 with with the distance of 9, and from 1 to 4 with distance of 7 here. Okay, so we need to find the minimum distance that we get in the path of 1 to 4. So we will go to 1 to 2, that distance will be 9, and 2 to 4 distance will be 5. The list of maintained distance from 1 to n must be there, and we need to return the minimum distance between any two cities that comes in the path of 1 to n. So that is what the problem really means. Here you can also get that 1 to 3 and 3 to 4, the minimum distance is 4 between 4 and 7. If no sorry, here distance will be 2, because first you go to 2, then you store that distance 1 to 2 is 2, then you come back to 1, that again you store the distance is 2, then you go to 3, distance will be 4, go to 7, distance minimum distance will be 2. So let's understand it in the mean of adjacency list. We go here, we need to track adjacency list of pairs that will store the node from which where we can go, and the distance that we will be going to need in order to reach that particular place. Okay, from 1 we can go to 2 with distance of 9, and we can also go to 4 with distance of 7. Okay, so this will be adjacency list for 1, and we will also form for others, and we will going to traverse from 1 over the adjacency list till we reach the nth node. We will be going to store all the distances that we cover in between this path, and then we will return the minimum distance. Okay, let's see the code, because this whiteboard will take you many time. I just need to go forward with the code. Okay, it will be easy to understand better. So here we have, okay, this is the adjacency list of n plus 1 elements 0 to n. So here n will be 4 not 3, so exact n plus 1. So here we will going to start by the bidirectional roads with their respective distance, and this vector v will be mapping all the distances or the path between 1 to n that we have covered, that 1 to 2 is 9, 2 to 5 is 4, like that, and then we return the minimum path or minimum distance between two cities that we cover while covering from 1 to n. Okay, so here we write a check function which take adjacency list that we have created, and n that is the target where we want to reach, and the starting position that is 1, vector v that will be mapping all the paths distance that comes from 1 to n, and visited vector for uh, what you can say that to stop that cycle, or what you can say, if graph is containing cycle, then we will need to break at certain time where we have already visited, so it will maintain that for that time. Okay, now here we come, check whether this node is already visited. If visited, then it is cycle, please return. If it is not, then mark it visited and go for the traversal. If this particular adjacency list first, or what you can say that element is n, we can reach toward n, then we can push the distance that we need to make through it, and oh, that this call is important because you need to find all possible ways. Here in this case 1 to 4 is a directly path that will be 7 cost. Okay, so you will just return 7, you will not go to 2, so you will need to traverse all the paths. You need to go to 2, then go to 3, then come back to 2, then go to 4, then you will get the minimum distance. In this case, if you are really want to go to the target, you will be just going to 3 and 3 to 4. The minimum distance will be 4 in this case. So this is not the what question really means. Question means you need to go for all possible paths, and you need to just give the minimum distance that comes in the path of 1 to n between any two cities. That's not really means 1 to n or 1 to any particular city. That only means one, you need to go from 1 to n anyhow, and you need to just give the minimum distance between the two cities that comes in the path of 1 to n. Okay, that's what it really means. So here we need to go for all possible. You can return in the case of what you can say that there is fixed path, or you just need to traverse the uh, nodes between two cities, not all possible out nodes such as 2, then you need to just return from here. We are going for all possible traversal, so we just call it. Okay, so that's all about this question. It was pretty much easier, not that much difficult, if you have a clear understanding of using adjacency list and DFS in cases to resolve over the cycles in the graph and go much more better. So that's all about it. I will be giving a good overview of the code if it is not visible. So this is what it should look like, and we will going to run here. It will be got accepted. It is a recursive approach, DFS approach. So that's all about for this video. Please consider to like, share and subscribe, and we will be meeting you in next video.